about the mathematics associated with machine learning. Most of the things we will discuss today, you are supposed to know it from your high school mathematics. If you already know it, then it would be just a revision for you. Otherwise, you can just, if you have forgotten and is not touch and you are not in touch with high school mathematics, then you can easily recall all those. Matrices will be a lot of use in machine learning, and we will see what are all that mathematical terms we need to know. As you know that in machine learning the most important stuff is mathematics. If you remember the first video, y equals to fx was the function which we tried to derive from a given data set. The machine will try to derive that, and using some complex algorithms which involves a lot of mathematics. So it is really important part of machine learning. We are going to cover it within today. So guys, let us quickly start with today's video. So the first term which we will discuss is tensor. It is like a 3D matrix with a 3D perception. You know that matrices are of the form I cross j, so it will be of the form I cross j cross k. So it is simply an array with more than two axes is called tensor. Example, in image processing we require a tensor with 3D depth perception. So to understand, you first of all you must know that image processing is an important aspect of machine learning, image recognition. So our, uh, in those stuffs we generally use this tensor. So we will understand what actually happens in that. You can see this is the view of the image with dimension, height and width. H cross W is the dimension of the main image. Now there is a 3D depth perception. What does it actually means? You must be knowing that all the colors which we have are a combination of red, green and blue. So there are certain values of red, green and blue in an image. Suppose red is of some 35%, green is of some 20% and the remaining amount is blue. So this pixel, the corresponding pixel of red, green and blue percentage combination will give a certain type of color, and that color of this pixel will appear on the front. So in this way we have all the pixels, each pixel with its own RGB values. So this setup is known as a tensor. Now we will understand this norm. In machine learning the length of a vector is known as norm. So this one is quite simple. You must be knowing this, that the summation of let us assume that a 3D vector in a Cartesian coordinates. How do you represent it? It will be simply a I cap plus b j cap plus c k cap. You know this. And the length of the vector is nothing but the magnitude, which is the root over of the sum of the coefficient of I j k. So here xi is the coefficient of a p coordinate system, and most commonly we can assume that p is 2, which is a Euclidean norm basically. So in a 2D xy axis, the length of a vector is known as Euclidean norm. Now this theorem is well known in probability. You must be knowing it from your high school algebra classes. So what is actually says, what is the probability of occurrence of an event y when an event x is already happened? So that is the intersection probability of y and x divided by the probability of x. So if we simply replace y and x by a and b and cross multiply, we will obtain this formula, and this is the computational formula which is used in commonly used in schools. You must be remembering this. And actually if you don't remember the formulas, there is nothing much going to happen actually, because it is the work of the machine. In machine learning this is the fun part, that even if you don't understand much of the formulas, the machine has to apply those formulas anyways. So you just need to have an outline of what is going on to be able to write a good code. You need not hard and fast memorize these formulas. So you will see application of Bayes theorem in while calculating probability in machine learning. So let us understand this Gaussian normal distribution. So it is also known as the bell curve because of its shape, and it is used in most of the offices and even colleges to rate the students or rate the employees. What actually happens? You see a peak there. Most of the employees are given moderate or average rating, and their salaries are going to increase at an average rate. But there are some employees who work hard and are very serious in their progress, so they are given a good grade. So what percentage of employee will get a good grade, that is also reserved according to the this Gaussian normal distribution. That what percentage of employees will get A grade, B grade and normal grade, and what percentage will receive a bad grade or bad feedback or be kicked out from the company. These are all pre-decided. What percentage will be what percentage contribution will be there. So you can see this, the position of low probability is at the extreme position, and at the mean position is the position of high probability. So you can see that if a flattened curve is there, you need to remember these terms, that if the curve gets flattened, you will see that there is a lot of variance but low bias. You can say like the more peak the curve will get, it will get a high, it will be high bias towards the mean position. Means I am being biased towards those who perform average. I am rating most of the students as average, so I am being biased. Such high bias is also not allowed and is not good for machine learning algorithms. And high variance and low bias, these are also not allowed. So what this actually high variance and low bias actually means, the significance of variance and bias in machine learning models will be explained at a later stage. Now you just need to know the terms, that's all. So if this slide is for anyone who is interested to know what actually is the formula for this curve, though you do not need to memorize at all these stuffs. Now we will see some statistical terms. We to compute the standard deviation, the formula is this, and a population and sample standard deviations formulas are different, you must know this. And variance is simply standard deviation whole square. Why we calculate standard deviation? To find the deviation from the mean position. You can say that we can then simply subtract our observation from the mean, right? Why need to square and do so much? So if you see, there may be deviations which are both positive and negative, right? And if we somehow find add those, we will get 0, some maybe or some less value. So actually the main deviation in to make it positive, even the negative deviations which we are finding, to make it positive we use this standard deviation. These are all high school knowledge stuffs. For your revision I have incorporated it in my slide. So these are some basic stuffs which if you have forgotten your high school algebra, you can just recall it quickly. The equation for the line is y equals to mx plus c, which m is the slope and b is the y-intercept. You can see it ax plus b, and you can see this quadratic equation 2-degree curve which has two solution because it cuts the x-axis 2 times. It has 3 solution because it cuts the x-axis 3 times, and there will be 2 points of minima. You can see the differentiation meaning. Actually we will be using calculus also in machine learning, so you need to know what is actually differentiation. Means the tangent of slope or dy by dx, though this very small del x and del y will give the slope, and integration is this area under the curve. You must be knowing all this. So there is one function known as logistic sigmoid. So it is a very useful function which follows the S curve, which saturates when the input is very high or very small. It is like logic gates in physics. In your physics high school course, you must have seen in the semiconductor chapter that there is a switch in transistor. In the transistor can be used as a switch, which can be on and off according to which, if high current or low currents flows through it. So it is like logic gate. You can say that in activation function, we'll see sigmoid probability is used. So it saturates towards the ends, 0 and 1. When it saturates, we are saying 1 is said to be on and 0 is said to be off. There is also one significance of this function, that you can find the derivative of this function at any point without actually calculating the derivative. So how you can do that? You just in your rough, you can just differentiate both sides of this equation. When you differentiate and do a lot of not lot a bit of calculation, you will find that this sigma f x, you can write sigma dash x equal to sigma x into 1 minus sigma x. You can prove this identity, and I will prove it at a later stage, because this activation function and stuff you need to know in your classification algorithm of machine learning, which is after even logistic regression portion and all. So it is the second algorithm which we will learn. So at that time I will prove those identities. So vector algebra is very important for machine learning. You must know the parallelogram law and the triangle law. You can just have a revision from these slides. So the vector dot product and cross product, you must be knowing this. AB sine theta with magnitude of A and B sine theta, and this is E is the normal vector. A general method to calculate is the determinant of IJK and the coefficient of A and B provided in the rows, and each coefficient multiplied together is AB cos theta. Now matrices is very important. You can see the types of matrices here: unit matrix, upper triangular matrix with the lower portion filled with 0. Similarly, lower triangular matrix, diagonal matrix, symmetric matrix, antisymmetric matrix, square matrices with I equals to j equals to n, and general size matrices like this. Symmetric matrices, the diagonal wise, apart from the main diagonal, other diagonally opposite elements must be equal. In an antisymmetric, the opposite diagonal, other diagonal opposite elements must be negative of each other, and the main diagonal must be 0. You must note that we are doing these basic stuffs because for the feeling of completeness, you don't need to memorize so much if you don't remember from your high school. These are stuffs which machine need to do. Our job is to do the programming, which we will see, and this is just it is for your in query and all, like you might be interested to know what actually algorithms are going on and how the machine is calculating, though it is not compulsory to know those, but you might feel that I should know what is actually happening inside the machine. So that's why I am just introducing to you all these basic stuffs too. So matrix addition are the corresponding summation of elements. You can see 3 plus 1 is 4, and here 4 plus 5 is 9. And you know this matrix multiplication. This row will be multiplied with this column in a dot vector multiplication order, and these also. Now this 3D matrix determinant, determinant of a matrix 3D, you can simply expand it like this. Now note one thing, a vector can be also represented as a matrix. This is very important, what I saw in machine learning, that many times they take the transpose of a vector. Now what does this actually mean? What is transpose of vector? The coefficient of the vectors, they just put it in a row matrix, and they multiply one row matrix with one column matrix. Can you imagine if there is just one row matrix and another column matrix? So the dot product of those two vectors are also exactly the same, right? So many times, to use the properties of matrices in machine learning, we will represent vectors as matrices, so that we can take use of the properties which we are going to learn in matrices. right? So this is a very important property which you must remember. So transpose and orthogonal matrices. The transpose of a matrix is just reversing diagonal wise opposite, and if transpose of a matrix multiplied by the matrix is coming to be an identity matrix, an identity matrix is something which has all its diagonal elements and as 1 and all other elements as 0. So such types of matrix Q is known as orthogonal matrix. Here you can see the inverse of a matrix. Direct formula is there. There are many other ways to find inverse using adjoint. You can search those up. So adjoint of a matrix, you can see the formula. These are the slides which you can just go through for your revision. And the properties of inverse matrices, these are the properties of inverse and transpose which we are going to use in machine learning. I told you that A and B will be two vectors. Actually we will represent it by matrices, row matrices and column matrices, so that in our calculation we can use these properties of matrices, and hence our calculation will be easier. So you can just go through the properties. A inverse of inverse A to the power some scalar of inverse is A inverse whole to the power that scalar. You can multiply the C and then 1 by C. If you take out, you will get the A inverse, and then transpose and inverse are interchangeable. The transpose properties are also here. You can go through and note it down. So Eigen matrices, an eigenvector of a square matrix A is a non-zero vector V such that its multiplication with A changes only the scale of V. In data preparation of machine learning, this is an important term, eigenmatrix. So what actually happens? We have a matrix V and we multiply another matrix or vector A. Now what we find, even after multiplying a vector by vector laws, if we multiply, we are just changing the length of the vector and nothing else. So this kind of unique multiplication, this coefficient k which is obtained in this multiplication is called the eigenvalue corresponding to the eigenvector. So once again, an eigenvector, this is quite important. An eigenvector of a square matrix A is a non-zero vector V such that its multiplication with A changes only the scale of V. So this square matrix A is our reference matrix and its eigenvector is V and K is the eigenvalue. You must remember this. In places in internet you will find it explained in a very complicated way and all. In Schrodinger equation, if you know, these Eigen matrices are used to solve those equations and all. So here I have written it in my own words to make it easy. Hope it will be helpful to you. So yeah, that's all from this video. So that's all from today's video. Thanks a lot for watching it till the end, and we are now done with the mathematics portion. And now once we are done, we can start with plotting graphs in Python, because the first algorithm which we are going to learn is linear regression. It will require a lot of plotting graphs and customizing it. So we will either within 1 or 2 video we are going to understand the pyplot library in Python and how we can plot complicated graphs using those, and how we can even customize those. Thanks a lot.